guys, I'm going to explain some faults that is associated with the charging section of the MKS Plus or MKS series of Voltronics inverters 1 to 3 kVA. Number one, you have a situation whereby these two terminals are causing short circuits, are short circuited. How do you confirm that? Turn your multimeter to continuity test. Place one terminal here, red. Place another terminal here, black. If it's continuous, this guy is likely the problem. But if this guy still looks fresh like this, it's not burnt, then it is okay. This is the problem. The bridge rectifier that's there is the problem. That's the problem. That's the bridge rectifier. I don't know if you can see that clearly. Yeah, that's it. Replace it. If this is not continuous, if the continuity test here fails, it's not continuous, and it's still tripping breaker, please do change the following path or receipt. Yeah, change the following MOSFET: Q9, Q20, Q21, Q22. You can see. Let me make that clear. Yeah, you can see the three of them there with that big high wattage resistor. You know, you change them, the three of them, replace them. Likely the resistor is going to be blown. You change them too. That when it's bad, it will cause a short circuit. Most time it's just one of them that will be bad. It will cause a short circuit, thereby taking more power from this bridge rectifier. That will cause this one to sense overload on from the battery and trips out the breaker. The third problem is you will have your battery meter, the battery gauge on the screen displaying as if it is charging the battery, but it's not actually adding any percentage. What you should do is you come to this guy and confirm that it is okay. Check that it is cranking out the necessary power to the MOSFETs. If there is no frequency or there's no PWM signal generated from here to the MOSFET gates, there are a lot of possible reasons why that's not happening. One could be that this guy is not giving power, which you have to check the circuitry, the resistors. Where the hell is this? Okay. I don't know if you can see that. Okay. This is the circuitry. You can see the output is coming from this diode and then splitted into three to drive the three MOSFETs. So you should check this circuit that everything is okay. The starting powers is there. The bootstrap system is okay. It is seeing the supplied voltage is there. This guy here, this is a diode that's supposed to bring down the input 220 volt or whatever voltage you have there, maybe 310. Bring it down through a help of some resistor to a suitable value needed by this resistor, the PWM current resistor IC that's here, by this IC, sorry about that, this IC. So once that diode does the right job, this IC gets the power that is needed, and you also check the bootstrapping system that is working okay. The bootstrapping system will first start the switching of this MOSFET here, there's three big MOSFETs there. Once that is done, the system carries up and then that's gonna run. there's this feedback circuitry here. This is a feedback circuitry that feeds back the power into the PWM chip. If these MOSFETs are blown, they will shift